Today, we're going to show you how to create this financial services asset management uh, demo in your Snowflake account. So this is a demo of a financial services asset management system where you can use that to populate trade, cash, and P&L to generate queries like this. So this is a system where it is built. The end result will be a FinServ AM database. It will have a trade table with about 2 billion rows, and that's driven by this trader table with 1,000 records. We're also going to connect to the data marketplace to get this Zeppo US Stocks Daily, where we have stock history of 35 million records, and that's from this origin, as you can see, is Zeppo.us Stocks Daily. That's from the data marketplace. So this is the end result. Over here, this is where it is open sourced on GitHub. As you can see, this is the why this demo problem statement, what we're going to see, how to install. We're basically going to run these 3 scripts right here. And we're going to show an optional setting where you can set the variable limit trader is X, and that allows you to stress test Snowflake, where 1,000 traders gonna do 2 billion records, so on and so forth. And how to run the demo is kind of out of scope. We'll have another video for that. And this is out of scope where it's just a stress test. Okay, so these are all open source. If we go to the setup folder, we're gonna run these 3 scripts in an environment, a new environment. So here's our new environment that doesn't have that FinServ AM database or the Zeppo database share. We have our 5 scripts that we got from the open source. So I'm just going to run these and then walk through it. So we're going to use an account that has the ability to escalate to account admin. So we're going to click run. As you saw, I selected that run all queries button. It's all running right here. We could see the open history here and see all of the queries that were run. And as you can see, everything completed successfully. So it created these schemas. Let's walk through what it did. It used the role account admin, created a FinServ AM admin. The AM stands for asset management. We add comments wherever we can so it's easier to understand. We create the warehouse, DevOps warehouse, and a data science warehouse. And there's an optional ability to create a user if you'd like. So over here, we're going to create the database FinServ AM, grant ownership of that, the database and schema to this FinServ AM admin role, grab ownership of those warehouses, which is the compute power that we just created, and also grant everything to sysadmin, which will bind you to grant the FinServ AM admin role to the existing built-in sysadmin role. And then we're going to create these 3 schemas, middleware, just for interim objects, not really meant for end users, Sigma writeback and Zeppo writeback. We do have some partners who have helped in open source tools to help you drive some BI and data science analysis. And they're going to demonstrate writeback, and that's on the roadmap where you can write back data to Snowflake. And then we're just going to come back to the FinServ AM public, which is where we'll be most of the time. So that's what script 1 just did. As you can see, it set up the roles, warehouses, databases that we needed. So we created the initial setup. Okay, moving to script 2, the FinServ data marketplace. So here, we're going to use the data marketplace to get a free data share from Zeppo. And then we're going to smoke test that with this query. So this query is going to fail. As you can see, the Zeppo US Stocks Daily database does not exist. So we're going to make sure to create our database with this name that we create from the data marketplace. And the benefit of this data marketplace is that we're getting real, live stock history data as often as Zeppo, the data provider, provides that data. So let's go to data marketplace, explore the data marketplace, and you can follow along. There's instructions that are written. Sign in if you need to. Okay, so here, while we're here, let's look at, there's other available data sets, but we won't go into that right now. Especially in the finance world, these are very important databases like S&P or FactSet, and that's instant real-time access. So if we go and search for Zeppo right here, we get this data marketplace share, and this is free of charge. So if we click on it, it has an explanation of what they do. So by the way, Zeppo is the creators of the Zeppelin open source notebook, and they have a managed service version that makes it easier for you to do your data science on Snowflake. So all you have to do is get data. As you see, the database name is default, which is the one that we use, so we do not have to change it. You have the option to if you want, but that will break our, you have to change our demo, so I don't recommend that. And then which roles do we want to give it to access to? So we can give this to, let's give it to 2 roles. Public is basically pretty much everyone in Snowflake, and importantly, the FinServAM admin role, which is the one that we just created. And all we have to do is accept the boilerplate. You can read these terms if you want, and create the database. Okay, and so that's it. It literally just created this database for us. We just take a quick look at it. So without any need to create the data definition language or anything, we get instant access to all of this data, the company profile, the stock history, and some symbols. Okay, so let's go back to our worksheets and let's run our smoke test query. Well, we could also refresh it over here. As you can see, Zeppo US Stocks Daily. And there you go. So we've got 10,000 records for profile, 35 million for stock history. Let's run our query, smoke test. And so what is this doing? It's getting the symbol for Apple, November 2nd. Okay, today. So it was refreshed as of November 2nd. So let's just run. Okay, so now that that is run, I'm just gonna run this script and then walk through what it means. So again, now that we've done the manual part of connecting to the data marketplace to get the Zeppo US Stocks Daily, I'm just gonna hit this all queries button and then run all queries because they're idempotent, meaning that we can run it more than once and get the same result. So it's running through it right now. Okay. So let's see what this is doing while that's running. It's using the role account admin. So we're granting access to the database to our role so that we can access that share. We're going to alter the power to a medium just to give us a little more power. And then it's going to do that smoke test that we just did. It's going to create a transient table. So this is the stock history that we're going to use. So occasionally we have witnessed duplicates in there, and this is just good to handle your data cleaning and data cleansing here. So this is the raw data that we're getting from the marketplace, and this just demonstrates how we can do a common table expression to remove duplicates in Snowflake. And we're going to add a column comment here, closing price used for all transaction. And here's again, we're going to create a transient table. Transient is just 3 different data types that we have in Snowflake. Transient just means we don't have our advanced time travel features enabled to save us money. The stock latest is just the latest available stock prices. So again, get to see a demonstration of a common table expression to get the latest available date that we're using Starbucks just to show us what data is available. And then here is just the company profile, which is just some basic market data about that company. So let's kind of recap what we did right here. We went to the data marketplace to get the Zeppo US Stocks Daily share, and this is going to provide the daily the updated stock ticker symbol data and the closing price that we have to drive our demo. All right, so moving on. All right, so here This one's going to run a little longer because we're setting the limit trader, the default is 1,000. And on extra large, so we're using the Snowflake benefit of being able to resize compute instantly. We're going to resize our data science warehouse this time because this will simulate how a data science team actually needs more power. Like when they're developing, they might use a small computing power, but when they go to production and do, let's say, 10 years of analysis, they might need an extra large or something big, like we're using an extra large to forget that computer. So let's just, while this is running in the background, I'll walk through this script. So again, we're going to hit this all queries run, and we're going to hit run. Okay, just refresh that over there. We will likely see these objects being created. The public table is creating these objects right here. We can see the open history if you want in the background to see as the queries are coming in. All right. So what's going on over here? We are sizing up to a double extra large. Okay, so what does the script do? It's setting up the DDL for these objects over here. You can comment this out and upgrade to more traders if you want, and that will have a magnifying effect, so that just like I had covered in the documentation over here, if it's 2,000 traders, it'll create 4 billion trades. 3,000, it'll create 6 billion trades. Okay, so to control the number of rows generated in trade table. So this is just a random number generator a random letter generator to create 3-letter traders and 2-level PMs. So PMs are portfolio managers. They're basically the managers of a certain set of traders. And then we're going to create a trader table, and this is that limit that we talked about. That's going to raise the limit for more stress testing. Again, you don't need to change this, just use the default. But for advanced use cases, when you want to do more, more stress testing, then you can raise the limit over here. Again, it's always good to have comments on your columns for data definition. So here we're just gonna, nope, wow, that's done. Okay, so by the way, everything is done. So let me just walk you through everything over here. As you can see, statements completed. Now just refresh. As you see, all the objects came in. So what is this doing? The watch list is just a table that we're going to have that shows you what a trader is authorized for, and we're just deciding what we're going to trade, and we did some definition of market cap. So this could be simulating like a compliance department that is authorizing what lists of which lists of equities are authorized or not, or financial instruments. Okay, so let's just recap really quick what we did here. We created some traders right here and are able to set the limit, and we have a watch list of what is authorized to trade, which would simulate a compliance department. Okay, moving on. So this is the watch list that we're creating. It just this is what the users can trade. So here is the kind of the big query that will allow you to populate the trade table. So this is the main table that is used to populate and trades made and the cash used for each of those trades. Let's focus on the comments. The unique key is symbol, exchange, and date. So as you can see, it's just doing a bunch of union alls to populate. And as you can see, this is how we generate the buy and the hold actions for Trader Charles. And over here we have for our inner join to watch list, buy, sell, and hold activities. Okay, so this just populates the trade table, and this is going to be about 6 billion records when you have 1,000 traders. Some sample queries if you want it. All right, so this is really the thing that controls everything. If you ever wanted to repopulate the trade table, you could use this as an example because the rest are views, and that helps a lot because you don't really have to like populate other views to get the data that you need for analysis. So here is position table, and these are what the assets are owned. What assets are owned, that's your actual position, that's your exposure. And we're going to demo window functions and running sums. So as you can see, some sums and overbuys. So that gives us the number of shares cumulative, and that helps us get the market value and the P&L. And this is impressive because it's going to be an analysis of 6 billion trades when people are querying, and Snowflake returns in generally under a second from what we saw in the actual demo. And if you notice, just kind of coming back to the trade table, over here we use the order by. Just because you order by when you create by Snowflake, Snowflake automatically uses this information to populate how the data is stored in trade table. And as you can tell, there's no indexes, no clustered indexes, no non-clustered indexes, no statistics, no vacuuming, no partitioning. Snowflake handles all of that for you and gives you fast performance. And that makes your life going a lot easier. Okay, and your query is very fast. Okay, so here's just like a share now. It's kind of like an intermediary table. And this share now view is just using position now. We could actually just wrap this share now view into this common table expression. So it would be like it would be like two nested CTEs in here. But the developer, I wanted to break it out so it's just I felt it was a little easier to understand. So basically what you hear is you're getting the shares that so you're using the is current value of the common table expression. So this is, if you wanted to use type 2 slowly changing dimensions, it's very similar in the sense that you have an is current flag. So that tells you in real time what is the latest value as the data starts coming in. So this is the numbers shares you have now and the cache that you have now. And so this is the number of shares, position shares, and cache that we have now. It's good to see the last value ranking, as you could tell. And then here is where we get the position now. So this position now is very important because this shows the value that you have right now. And as you can see, it's using that share to get that. Okay, and then finally, it altered the compute down to the small, as you can tell right here. So, and then furthermore, it's suspended. So this is great for you to learn how to resize compute, suspend. So let's recap what we did over here from the midpoint. Okay, so we created the watch list. We populated the trade table. If we refresh right here, we can see how many objects are in the trade table. As you can see, there's 2 billion rows in the trade table, and there's 1,000 rows in the trader table, as you can see right there. Okay, and then these are just views that we have. As you can see, position and position now, these are views. And when you query this, it's going to hit the trade table and yet be highly performant. Okay, so from now, all of these queries should work. So let's actually, we can run these interactively. So this is the demo that we have a separate video for. But as you can see, it all works right now. And this is a new environment that I've never run it in. As you can see, I'm just going to fly through these. So as you can see, position now, the traders that you have, again, the position that you have now. And notice this is real time. Like, I didn't create any indexes or anything. You saw the real-time scripts that we have. As you can see, 2 billion trades. This is views over 2 billion trades without any need to partition or anything, or index. What is my position in P&L? That's the data definition language that we see. That trade table that we populated, the metadata for the table. As you can see, this is a stock history. This is from the data marketplace, and the latest value, the latest values. All right. So this concludes our video today. Let's just do a quick recap. We created the objects that we need for the FinServ AM database. we connected to the data marketplace share named Zeppo to get our stock prices. So these are actual closing stock prices. And then here we allow ourselves to create 1,000 traders and then 2 billion synthetic trades. And we resize our compute as we need it. And so that is your, this is how to build a financial services asset management demo. Thanks for your time.